Hey everyone, welcome to another coding session. Today we are talking about caching in NestJS, how to speed up your APIs and improve application response time. Why is caching important? Imagine a request to your API where the application needs to perform some time-consuming operation, like loading data from an external service or reading from a file or some complex database query. Without caching, your application will have to do this work over and over again for every request. With caching, you can store and reuse frequently requested data, making the application much faster. This diagram is a simple illustration of how caching works. This time the same request comes in, we first check in the cache if the data exists. If the data is there, we just return the response. Otherwise, we do the time-consuming operation once again, save the data in cache, and return response. So that subsequent request is going to make use of what is in the cache. This is what we are going to accomplish in this video. We will start with a little setup and configuration. We're going to install some packages and do some setup in the code. And then we implement some manual caching, manual approach, where we're going to see how to put item in the cache store and read items. After that, we look at auto caching of the responses. This is going to save us, minimize the number of codes we need to write to implement caching for the APIs. And then we look at how to override some defaults that are set in the caching configuration. Finally, we are going to take things a step further by using Redis as our cache store. That is Redis for the caching. Okay, with this in mind, let's dive into the code. Let's get started with the coding part by creating a new NestJS project. So I'll head over to the terminal using the Nest CLI. I'll say Nest new. Give the project a name. Let's call this Nest Cache. You can give it any name you want. I'll wait for the installation to complete. With the installation completed, I'll go into the project folder, Nest Cache, and npm run start dev just to confirm that everything is working fine. Of course, it should. All right, the application is up and running. I'm going to stop it. Let's go over to NestJS documentation and do the cache setup. We are going to install some of the packages we are going to use in this project. For now, we are going to install these two. When we get to Redis, we will install another package. So I'll copy this command, and over here in the terminal, I'm going to install those two packages. Here is the project open in VS Code. What I've done is to add a configuration file that I like to have in my project. This is for VS Code. It doesn't have anything to do with caching. Basically, I want VS Code to automatically format files when I save them. And this one is for debugging. Again, you can ignore this. All right. The next thing we are going to do is to go to App Module and configure the cache module. So over here, I'm going to import cache module and register. Call the method register. When you leave it like this, it is assumed that the TTL, that is the time for an item stored in the cache to expire, is 0, which means it never expires. But that's not what I want to do. Instead, I'm going to set a TTL of, let's say, 5 seconds. But why am I getting an error? But this value is in milliseconds actually. So it should be like this for 5 seconds. The next thing I'm going to do is, instead of having to import the cache module in every other module that needs it, I'm going to make this global, so I don't need to import it in every place that it is needed. With this simple configuration in place, we can begin to cache things. We are going to return to this configuration later, but let's leave it like this for now. The next thing we are going to do is to see how to manually put things into the cache, retrieve them, as well as how to clear the cache items. For this, I'm going to modify this controller. Actually, let me start from the service class. So I'll go to app.service.ts. To make use of the caching, I'll add a constructor here. Let me get the code from documentation to save us some time. What we need to do is to inject the cache manager using this injection token. I'll come over to the constructor and inject the cache manager. Let me fix the imports. Make sure to import cache as well from cache manager. Let me change this method to, let me call it manual caching, whatever, and remove this return type. I'm going to assume that this method will return anything at all. Let's say data to be equal to array of 1, 2, 3, doesn't matter what is being returned. And right here, I'm going to return data. But first, what I want to do is to check if this data exists in cache. If it exists in the cache, I will return from the cache. Otherwise, I'm going to fetch it afresh. For this, let me just stay a little bit organized. I'm going to have a private read-only cache, not in caps, cache key to be equal to, I don't know, whatever. Or let me put this in a different file altogether. I'm going to call this constants.ts and export const cache key. It should be equal to anything at all, whatever. Okay, so I'll come over here. The const cached data to be await this dot cache manager dot get, but I'll use the key like this, cache key dot whatever. Make sure to import that. Now, if the value exists in cache, I will just return that value. Otherwise, I'm going to fetch it afresh. By the way, let me simulate a situation whereby we're actually fetching data, maybe from database or something like that. I noticed that I lost this part of my recording. That's the next code that we're going to see. So let me re-record this. Basically, what I did was to, instead of having this hard-coded data, I want to simulate a long running process like fetching data from an external service or reading a file, something like that, just to for this demonstration of why caching is important. So I have this method that I call time consuming operation, and it takes 3 seconds to complete, just utilizing set timeout here. And in the manual caching method, I'm going to call that time consuming operation. And if you could recall from the start, we say that caching can help us to speed up the API. And what happens is that if this data already exists in the cache, it is returned. Otherwise, this time consuming operation is performed and we update the cache. When we get the data, finally, we return that data. I also want to add some login here just for us to see in the console when we are reading from the cache versus when when we don't have that item in the cache. But when we have the item in the cache, that's a cache hit. When we don't have the item in the cache, that is a cache miss. This is just for us to see in the console. Nothing so special here. All right. So with this method here, our testing is going to make more sense. I also showed how to delete an item from the cache store using the cache manager.delete, as well as how to clear all the items in the store using the method clear. And then I added a second method. This method, what it does is to call this time consuming operation directly. So there's no caching happening here. Then over here in the controller, I called those two methods. So I have two endpoints, one to the base URL, and this one the path /foo. Now is the time to test the caching. Over here in Postman as a client, I've added the two endpoints. This is the one for which we implemented the caching, and this other one doesn't have caching. So I will put my eye in the log. Okay, let me start the application first. npm run start dev. The application is up and running. Now I'm going to send the request. What will happen is that for the first request, because there is no cache, it's not going to read from the cache. So I'll send the request. Where's the log? Okay, let me change the log to debug so it is easier to spot. I'm going to change this to debug and this to debug. And the application will restart, and that will clear the cache, the memory cache. All right, I'll send this request again. You will see that what we have is cache miss because the item did not exist in the cache. Let me restart this. So we also notice that the response took about 5 seconds, which is 3 seconds, which is how long this process takes to complete. I'll send the request again. You can see that it's taking some time, about 3 seconds. We get the response, and that was a cache miss. But if I send the next one, it's going to respond faster because this item exists in cache. Send the second one. Oh, I know why it's not responding faster. My TTL is too low, 5 seconds. So as I was talking, 5 seconds has passed. I'm going to change the TTL to 20 seconds to give me more time, or 10. 20 might be too much. So my TTL is 10 seconds, and we are going to repeat this. Remember that when the application restarts, it clears the cache from the in-memory store. I'm going to send this again. It takes some time, and of course, it is cache missed. But when I send it again, it is fast. That is cache hit. I'll send it again. It will continue to be cache hit until 10 seconds has passed. So it's going to recompute the cache, and that is why we have a cache miss here. So what we can conclude from here is that this manual approach of adding items in the cache with set and retrieving them works. The next thing we are going to do is, instead of implementing caching like this manually for all the endpoints or all the requests where we need to cache the response, we are going to do what is called auto caching of the response. To achieve that, we'll come to this providers array and apply cache interceptor globally. So let me go to documentation. Here we can see how to apply auto caching. I'm going to copy this, go over to providers array. Make sure to import the dependencies. With this, we are telling NestJS to cache responses for all the GET requests, all the GET endpoints in the application. Before I apply this, actually, let me demonstrate the other. Let me show the other endpoint where we don't have the caching in place. Remember that I have two endpoints in the controller, and that this one doesn't make use of cache. If I send the request, it's going to take 3 seconds. And if I send it again, it will take, oh, why is it not taking cache hit? Just a moment. Why does it say, oh no? So this should be get data too. I forgot to change the method that is called here. All right, I'll send the request the first time. It takes long. Send it again, it will take long because there's no caching applied to that endpoint. But if I go to app module and apply caching for all the get requests, you will notice that there's a difference now. If I send the first one, it's still going to take 3 seconds, but subsequent ones will be from the cache, of course, until it expires. Takes time. Send the next one, it is fast until 10 seconds has passed. So almost there at 10 seconds. So you can see that with this piece of code here, we are able to apply caching for all the get endpoints. But what if you want to utilize this auto caching feature, but don't want to apply caching for all the endpoints, or you want to override the default configuration like the TTL for some routes? What you can do is, let me comment this thing out. I'm going to come back to it. I will go to this controller. Actually, let me make a duplicate of this controller. So I'm going to call this controller 2 and app controller 2. Make sure to have that imported in the controllers array, app controller 2. Okay, and I'll go to Postman and add the endpoint for controller 2. What did I call it? Let me call it CTL 2. No, not this guy. It's this one. And over here in Postman, so this is going to be controller 2 / foo, and duplicate this. And this is going to be, what does this say, product? It's going to be route 2. And this route 2. All right. If I send the request, of course, it works like the other one. But let's do something. What I'm going to do is, instead of applying the caching globally, I'm going to apply it to individual controllers or individual routes. And the way we do that is to say use interceptors, cache interceptor. With this, all the methods in this controller, all the get route handlers, their responses will be cached. We can try this out by first, let's try the route 1 / foo. Remember that this guy is not cached. And because we don't have that interceptor applied to it, it's not going to be cached at all. So you can see that for every request, it takes time. Now let's try the same thing with the route 2 / foo. I'm going to send the first one. It takes time. But when I send the second one, you can see it is fast, because all the get endpoint in that controller is cached. So this is how you can apply caching to individual controller. We can extend this to individual route as well. So I can come here and the missing import, save this, and once again you will notice that the caching applies to this endpoint. Send it again, the caching is working. Another thing we can do is to override the global default, these default configurations. For instance, I can decide that the TTL, even though it's 10 seconds here, should be 60 seconds for this specific route. So what I can do here is to say cache TTL to be 60 seconds. Of course, you can do the same thing at the controller level with the same decorator. Now the TTL for the endpoint is 60 seconds. Let me drop this one to 5 seconds, but you will notice that this will not apply to this particular endpoint. So I head over to Postman and call that endpoint. Now the item is in cache. I'm going to continue clicking more than 5 seconds. You can see that 5 seconds has probably passed, but it is still fetching from cache because the TTL was changed to 60 seconds. Remember how we gave this cache a key? We're using key to store and retrieve the cached item. By default, NestJS is going to generate some key for each of these endpoints based on the route. But what you can do is to, let's say for example, for this one, you can change the cache key to, come on. So you can change the cache key by using this decorator cache key. What is going on? Oh, I see the problem. I have typo. So it is cache key like this. This is how you can set cache key for the endpoint. Now is the time for us to take this one step further by using Redis as the cache store. So I'll come over to this documentation where it says using alternative cache store. This shows us how we can configure different cache stuff. You can also use multiple cache stores, but take note that the first one in the array of stores is the default one. I'm going to install the package we need for this, for making use of Redis. I'm going to stop the server, npm install Redis. While that is installing, let's go ahead, let's just use this example here. It is using both in-memory and Redis. So I will go over to the code and go to app.module.ts. Actually, I'm going to change the configuration style to use asynchronous. Oh, that's exactly what is here. I'm going to use the async syntax. So I'm going to, instead of removing this, I'll add the new configuration here and fix the imports. So actually, so for this cache store, I'm going to install a package cacheable. So npm install cacheable. While that is installing, let me fix my import. Come over here and let's hope that I got all the imports correct. Why is this? I think it's ESLint because I did not use await in this function. And, so I'm not sure why I'm getting this error, but I've fetched this error before using trying to use this create key v to configure Redis store. By the way, take note that the store at the top becomes the primary store. Because we are focusing on Redis, let me move Redis to the top, and let me just comment this guy out. You've seen that we can configure multiple stores. That's the most important thing here. So for this error I'm getting using this create key v function, I don't know why that is happening, but I found an alternative way that worked for me. Maybe later you take time to find out why that create key v function is showing an error, if that is happening for your use case as well. But I'm going to use this approach for my configuration, and this is coming from the package, the same package cacheable that we used down here. Then this is coming from key Redis. Am I missing something? Oh, this should be a comma, not a dot. All right, with this we have, oh, this is my Redis connection string. I'm not using any username or password for my Redis, so I'm going to change this to that. With this, we have configured Redis as our cache store, and of course in your production application you probably have this Redis connection string stored somewhere, maybe in your environment variable or something like that, but I'm going to leave it hard coded here. Now I will go over to the terminal and let's run this test again. Npm run start dev. Then what are we going to test? Oh, again, I'm going to set TTL and global to true for this. So why is there an error? That should be, I suspect it is because I typed package log here instead of package log.json. Come on, why am I doing this? All right, I will remove the two of them now and run npm install again, see if the issue goes away. Okay, with that installation complete, what I wanted to do was to run npm start dev again. Okay, let's hope that it works this time. All right, that solves the problem. I'll head over to Postman now and let's see if our caching with Redis as our only store is working. So head over to Postman and call this, by the way, let me enable the global caching again. We have seen how to apply to individual endpoints and controller as well. So I don't need these use interceptors anymore because I'm making use of global caching. Where else did I use it? I think that's the only place. Okay, I'll go here, and this route has manual caching implemented. I'll send this request. So it is a cache miss in the beginning. Send it now. Cache hit. Now cache miss because 5 seconds, I think that's the TTL, has passed. And we can go to Redis to verify that we have something stored there. To do that, let me actually give myself more time. I'm going to set this to 60 seconds. That is 1 minute. The application is running again. Send this request. And initially, of course, it's a miss. It's a hit. What's going on? Yeah. We are not seeing anything logged here because the caching happens automatically. That is for all the endpoints. Remember that before we had to, before we would see this log here that is a cache hit. But because this manual implementation has been overwritten, by the auto caching of responses here. The request didn't even get to this method, this part of the code, when the data is in the cache. That's why we are not seeing this anymore. Let me send this again to have the cache afresh in the store, and I'll go to this Redis CLI scan 0. I think this will give me all the keys. So you can see here that we have some keys, and for this endpoint, remember we store the data with the key, whatever that is coming from here. This is the key we use to store it. By default, the package you are using, the key v, is going to use this prefix key v like this. If you want, you can override that with I think namespace here. So I'm going to override that. The application will restart and send the request. Now it is in the cache. Over to Redis and 0 again. You can see that the prefix has changed to my app, which is what I have used as the namespace. So with this, we can confirm that using Redis store works. Okay guys, I believe we've covered all these items we listed. We're going to cover. We started with setting up the caching in the app.module.ts, and we've seen how to manually interact with the cache store, as well as how to use the different cache stores. I hope this lesson makes sense. Until next time, enjoy coding.